Hi, I'm Anusha, and in this video I will be showing you how to declare a matrix on MATLAB and find its row reduced form and find its rank. So let's begin. So suppose we will be declaring a matrix A which is 3 cross 4. We will be declaring it, when we declare it, it will be enclosed in square brackets. And at the end of each row we'll have a semicolon to indicate the end of the row. So if we run this, we have our matrix defined over here. So now let's find its row reduced form. So there are three conditions that our row reduced form must follow. If there are any zero rows, it should be at the bottommost row. All leading non-zero entries in each row should be to the right of the leading non-entries of all above rows. This means that if say 3 is our leading non-zero entry in the first row, our next our leading non-zero entry in the second row can be in place of the 2, the minus 1, or the second 2. It can't be in place of 1. And the third condition is entries below all non-zero leading entries should be 0. So again, if 3 is our leading non-zero entry in the first row, in place of 1 and 4 there has to be a 0. So let's first convert the first element of the second row into a 0. So that'll be done by taking R2, which becomes R2 minus 1/3 of row 1, and we will write this like so. This form represents that we're accessing this entire second row and modifying it, and the colon represents all columns of that second row. So in case we put a number, it'll act in place of the colon, it'll access a particular element which maps to those two coordinates. So if we run this, oops, we see that the first element of the second row becomes 0. Now let's convert the first element of the third row into a 0. So that'll be R3, which becomes R3 minus 4/3 of R1. So let's just copy this line so it becomes easier for us. R3, so row 3, that is, minus 4/3 of row 1. So if we run that, we see that both entries below 3 of the first column becomes 0. Now we see that if we subtract the second row from the third column, second row from the third row, the third row becomes 0 entirely. So let's do that. R3 becomes row 3 minus row 2. Row 3 becomes row 3 minus row 2. So when we run this, we see that our entire last row becomes 0, and now we see that there are two leading non-zero entries in the first row and in the second row, one in the first row and one in the second row, which is 3 and 1.6667. Now these two elements are called the pivots of the matrix. And so now let's go on to find out the rank of the matrix. So the rank is the maximum number of linearly independent rows or columns in a matrix, which is also equal to the number of pivots in the row reduced form. So over here we see we have two pivots, which means that the rank is supposed to be equal to 2. So we can also check that using the rank function uh, in MATLAB. So if we run this, we see that the answer is 2, which cross checks and confirms that the number of pivots is equal to the rank of the matrix. The end.